We would like to continue our study of measures of position and discuss percentiles. Think about percent. Percentiles are those where we have broken up the data into 100 even pieces. So the kth percentile, denoted by capital P, lowercase k, this is a subscript of the set of data, is a value such that k% of the observations are less than or equal to the value. So if I look at p sub 2, that means that 2%. So 2% are less than or equal to that particular value. When we talk about the 98th percentile, p sub 98, we're saying that 98% of the data is less than or equal to this value. We see this a lot in education. Think about some of the scores that you have received over the years. Maybe it's SAT, ACT, or another standardized test. And when you get the results, you get that you're in the top 98th percentile, or you're in the top 87th percentile. When children are measured when they're infants and newborns, the doctors give them a rating as far as being in the 75th percentile of their age. What this means is that 78% of other children their age are actually smaller than them. Or on the SAT, ACT scores, if you have a 98th percentile, that means you have scored better than or equal to 98% of those other students that have tested on that particular exam. So what we want to do when we're finding the data value considering or corresponding to a given percentile, meaning I give you a percentile and I want you to actually figure out which data value goes with that. The first thing that we need to do is we need to arrange the data in increasing order, from smallest to largest. Then we're going to compute a value called L. L is just the location of that data value. It is not actually the data value. It's not actually the number that we're looking for. We're just going to calculate L. If L is a whole number, then what we're going to do is we're going to take that position plus the next position, and we're going to take their mean. So if it's, let's say it's 4, I'm going to take the 4th position and the 5th position, the numbers that are there, and I'm going to average them. Let's just look at an example for a moment. If I have 7, 9, 10, 12, 15, and 20. I have 6 values here, and I'm going to, let's say, I want the 50th percentile. Let's just make it equal. 50th percentile. What I'm going to do is I'm going to take the location as equal to 50 divided by 100 times 6. 50 divided by 100 is 0.5 times 6. So that gives me 3. Well, because this came out to be a whole number, I'm going to take the 3rd position and the 4th position, and I'm going to take their mean. So 10 plus 12 is 22, divided by 2 is 11. This number is the 50th percentile. Keeping these same data values, so I'm going to look here, keeping these same data values, if I want to find, let's say, the 10th percentile, I'm going to take 10 divided by 100 and then I'm going to multiply that by 6, and I get 0.6. And this is again the position, whenever I get a number that is not a whole number, here is one of those cases where you always want to round up to the next higher whole number. So in this case, our L was 0.6, so I'm actually going to look at the first position, which is 7. And then if I take the 20th percentile, so this is the 10th, if I look for the 20th, that's going to be 20 divided by 100 times 6. So 20 divided by 100 times 6 is 1.2. Normal rounding rules tell me to round down, but in the case of percentiles, I'm always going to round up to the next number. So in this case, 7 was the 10th percentile, and 9 is the 20th percentile. So let's look at an actual example. The following are the number of grams of carbohydrates in 12-ounce espresso beverages offered at Starbucks. We want to find what is the 31st percentile. The first thing that you need to do is put all of these data values in order. So I suggest you pause the video and go ahead and put those in order. Okay, so I have put these values in order from the smallest number up to the largest number of 59, and I want to find out which one is the 31st percentile. Well, looking here, I have 22 total values, so my N is 22. So I want to find the location of the 31st percentile, so I'm going to do 31 divided by 100, and I'm going to multiply that by how many values I have. When I do this, I get 6.82. Always round up if it's not a whole number, so I'm going to round up to 7. So I'm looking for the value that is in the 7th position. 1, 2, 3, 4, 5, 6, 7. So 24 is the 31st percentile. You can do this with any of the percentiles, and just make sure that if you get a whole number, you take the mean of that position and the next, or you can get a number that's not a whole number and you want to just make sure that you round up. Now let's look at, what if I have the numbers and I want to estimate what percentile each value is? When doing so, I want to arrange the data in increasing order, again from smallest to largest, and let X be the data value whose percentile is to be computed. Remember that just lowercase x is always representing whatever data value. We use the following formula, and that is that the percentile is 100 times, and then I have this fraction. First we have the number of values below x. That does not include x, that's strictly below x. We always tack on that 0.5. The reason why we tack on that 0.5 is again to give us that buffer room, because we probably don't have the population. This is my numerator. The denominator is the total number of values in the data set. So this is my, say, sample size, my N, if you were, total number of values in the data set. When we're talking about percentile, we always round to the nearest whole number when we're actually finding the percentile. This gets a little confusing for us because whenever we are looking for the location, like in the previous examples, we always round up. Here, we're wanting to find the percentile, and so in this particular case, we always round accordingly. So let's look at an example. We're going to stay with the same Starbucks drinks, and this time there are 38 grams of carbohydrates in an iced dark cherry mocha. What percentile is this? First thing again that we need to do is put these in order from the smallest to the largest. So here we have the data values in order from the smallest to the largest, and I'm looking at the one with 38 grams. Right here is 38 grams. So whenever I want to find the percentile, I'm going to take 100 times, and then I'm going to count how many values are below that number. Again, not including that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. Add in that buffer room, and then there are 22 total. Whenever we look at this, make sure that you do your multiplication and division in order. So I'm going to leave the 100 out here, times 14.5 divided by 22. So 100 times a 0.659. When I multiply that by 100, I get 65.9%. Round up. So again, when I round this up to 65.9, I round it up to 66. The iced dark cherry mocha is in the 66th percentile when we're talking about the grams of carbohydrates in a 12-ounce espresso beverage at Starbucks. Go ahead and practice calculating percentile, finding the percentile, finding the position, and let me know if you have any questions.